Hello, I'm Chuck Martin, and welcome to the Voices of the Internet of Things. With me today is Brandon Robinson, co-founder and chief executive officer of Horizon Aircraft. Brandon has been in the Canadian Armed Forces as a fighter pilot and a fighter pilot instructor, and has been a line pilot at Top Aces. At Horizon, Brandon is leading the team developing the next generation of hybrid vertical takeoff and landing vehicle. Welcome, Brandon. Good to have you here.
Hey, thanks, Chuck. Really appreciate the opportunity.
So tell everybody what your flying vehicle is, because it's a little bit different than some of the others that are flying around, as it were.
Yeah, so we're designing a hybrid electric vertical takeoff and landing machine. So essentially, an aircraft that can take off and land vertically just like a helicopter, but en route, it can travel about twice as fast as a helicopter, is cheaper and much safer. So if you think the world can use a cheaper, faster, safer helicopter, then I don't really have to say much more. I can just mic drop and leave at this point.
So is it really competing with the market, the helicopter space, or with airplanes, or with other vertical takeoff and landing vehicles? Where does it fit?
Yeah, so first I'll start with your last point. The typical VTOL market or eVTOL market, the classic air taxi to take off from one spot in the city and go maybe 50 miles and land at another sort of vertiport. We're not really competing with those folks. We see ourselves very much as a complementary service. So we're about twice as fast as those machines. We can travel about four times further. And that's because we have a hybrid electric engine on board and we have a very unique configuration. As for the first question, about 75,000 helicopters operate on a daily basis around the planet. Half of those, more than half of those, actually about 60%, simply go from one point to another point. They don't, but there's just no landing infrastructures. And so they need the helicopter to be able to take off and land without any airport infrastructure. And so half of the global helicopter fleet, over half of it, simply goes from one place to another. And our machine is going to be highly disruptive for those machines.
Aren't helicopters high maintenance as well?
Well, yeah, I mean, that's one of the problems. The helicopter is essentially trying to fling itself apart on a daily basis, right? Like it's got this awkward. There's a reason why birds don't, fly around like with their wings just doing this all day long, like pop, 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 right? The most efficient way to fly is on normal wing-borne flight for larger machines and, well, birds in this case. And yeah, and so we wanted to create a machine that could take off and land just like a helicopter, but fly 98% of the mission just like a normal airplane. So our machine specifically has proprietary and patented technologies where the wings transform and they close, much like a commercial aircraft just retracts its flaps and its slats. Our aircraft does the exact same configuration change, except it hides the vertical propulsion units within the wings, and it flies again 98% of the mission just like a normal aircraft. And so with that, a low drag, extremely efficient configuration, it can fly faster, further, and is much safer than normal helicopters.
So you've been a pilot, like a serious pilot. So what's your background, and how did you get in? How did you phase into this?
Well, my wife would laugh if you called me serious because I'm virtually never serious about anything, but I am very serious about flying airplanes, and I have been flying since, well, in airplanes since I was 6 months old. My grandfather, who was a World War II bomber pilot, my father, who's been flying since he was about 14 years old, um, put me in an airplane at a very young age, and I've been flying airplanes since I was about 3 years old. My grandfather and my dad would stick me on the seat. I would stand on the seat of our family airplane and fly it around. A 20-minute mission would be, probably take them about an hour and a half as I sort of, meandered my way into the right sort of location. But yeah, but yeah, I was a Royal Canadian Air Force fighter pilot. I flew F-18s for the better part of 17 years in the Air Force. I did the Canadian version of Top Gun, which is fantastic. Met a bunch of really good buddies, and we sort of all succeeded together. And then afterwards, I flew for one of Canada's most epic companies, a company called Top Aces, founded by Didier Toussaint and Paul Bouchard, two true Canadian patriots that founded a company that essentially we flew jets in the private sector in support of allied forces around the world. So we went and we would teach um, and help armies learn to do forward air controlling, so call in airstrikes. We would train with the Canadian Navy, help calibrate their ships' radars, and essentially just do adversary support. So we were the bad guys, and at about one-sixth the cost, top aces can train, can put up an adversary support squadron, and fly and train the blue forces, so the good guys around the world.
So you have to know a lot of people in the flying arena. What do they all think of what you're doing now?
Well, you're just going to get it from a very straight shooting ex-military guy. They're frankly relieved, right? This space, and there's a lot of people and a lot of companies doing some very amazing work in this space. The Jobies, the Archers of the world, those companies will produce and certify aircraft that are going to do some amazing things. But the space has been, I think, looking for a more practical solution for quite some time. A machine that can fly in bad weather, in cold weather, in icing conditions, and maybe a machine that doesn't. It's not tethered to any charging infrastructure. So all the other aircraft are all electric machines. They're going to have to fly to a place that has a high power charging network, or at least capability to be able to plug in their aircraft to recharge them. Our aircraft is hybrid electric, so it has gas burning turbine on board. It can operate completely independent of any charging infrastructure. So when you land at some remote location to do some amazing work, maybe you're dropping off critical supplies to a remote community, maybe you're picking up someone that's injured, you don't have to find the world's longest extension cord and plug it in and wait for 4 or 5 hours. You can literally just land. As long as there's jet fuel on board, the aircraft can recharge itself in 10 to 15 minutes, and then you can take off and do some more good work.
What do you see as the first big uses? I mean, it seems like an obvious military application, but I mean, it's not. You're not really looking at the shuttles like the Joby and Archer kind of air taxi sort of thing. This seems like it's heavier duty.
Yeah, much heavier duty, much faster, and again, about 4 times the range. This is a machine, as a military pilot, I would have loved to have had this capability on board. So at the peak of my career, I was planning and leading NATO coalition strike missions and training, where we'd go practice and pick up down pilots from beyond enemy lines. We would go and insert special forces folks in hot spots and then retrieve them, etc. We were always um, essentially limited by the slowest aircraft in the fleet. So we'd be flying around at 600 miles an hour at 30,000 feet, and the helicopters were the ones doing the hard work. They'd go in and they would actually land at a some sort of unprepared location, drop off people. The helicopters are so slow. I mean, you look down at your screen, and I'm not kidding it. You're wondering, like, have they even taken off yet? I'm not even sure. Like the little green dots are not even moving. So we have an airborne network. I can see all the different airplanes and where they are and how fast they're moving. And an hour later, the helos have gone like 100 miles, right? And it's just the most painful thing to watch. We'd have V-22 Ospreys, which were great when they weren't broken and they actually got airborne. It was fantastic to have those folks in the mix. They do great work. But a machine like the one we're building, cheaper, faster, easier to maintain. I would have loved to have had that machine in the fleet from a military perspective. So, special forces, infiltration, exfiltration, casualty evacuation, you name it. If you got to get it in and out of a tight spot where there's no runway infrastructure, this airplane would be great. The one that we're building. On the civilian side, anything where you need to get something from point A to point B quickly and efficiently, and by the way, about 75% cheaper per unit mile, this machine will be incredibly compelling from an operational perspective.
So it sounds like it's more of a B2B kind of operation than a business to consumer operation. Is that accurate?
We're talking to a lot of different folks. We're talking to, of course, the militaries, like I spoke about. We're talking about operators, and there's a lot of helicopter operators around the world that simply move things around, people and stuff, right? Great example is I was at a rare earth mines conference in Toronto, Ontario, Canada, about 2 months ago. And I spoke with a lady who had built an entire company that dealt with mining logistics and eventually um, built that company into a mining operation as well. They had a fleet of helicopters, called them 20 helicopters, that simply just moved people and stuff around in preparation to, again, extract those rare earth elements that are really important to the future. She said, honestly, I mean, if you had a machine that was twice as fast and was 75% cheaper to operate than these helicopters that are, by the way, always broken, yeah, I would change my fleet. I would swap out my fleet tomorrow. So we're talking to lessors who have the capital to lease or sort of buy a significant amount of these aircraft and then lease them to operators. And then on the operator side, being able to lease these machines that are so much cheaper to operate, easier to maintain, safer, faster, to do the work that they're doing on a daily basis. That's a very compelling case.
Where does weather fit in? You mentioned weather and clouds and ice. Talk about that a little bit about this in terms of the whole vertical takeoff industry.
Yeah, and so here's the thing that, again, this is from a very operational background. Again, I've been flying in airplanes since I was a couple months old. Um, it's not always a nice environment, right? And I use this example. So you take off in Southern California, you're in San Diego, it's 15 degrees Celsius in the morning. Call it 60 degrees, whatever, 60 degrees Fahrenheit for the US folks. You want to travel like 100 miles away, you're going to go to 4 or 5 thousand feet to do that. You just take off, you go up 5,000 feet, and then you land. What's the temperature of the air at 5,000 feet on a 15-degree day when it's 15 degrees Celsius on the ground? The answer is that it's zero, right? It's essentially winter time. You're flying around in winter conditions all of the time. Batteries hate it. And there are only a handful of helicopter types in the world. S-92, the AW139, 169, 189 series that have, it's called RIPS and FIPS, like the rotor icing protection system, uh, essentially systems on board a helicopter that allow you to fly in clouds that have known icing. Almost every single helicopter in the world cannot fly in clouds that have any sort of icing conditions. And we're building a VTOL that is built for that. We're targeting flight into known icing conditions, flight into clouds under what's called IFR, instrument flight rules conditions, essentially using the airborne network that is always available for commercial aircraft and fitting right into their traffic patterns. So not doing anything special from that perspective. That is very unique in the vertical takeoff and landing world. Most helicopters crash because they're trying to avoid clouds and fly under them, right? It's not a very popular thing for an operator when a bunch of clients show up and there's some clouds and they don't understand why they can't go flying because you're like, well, the clouds, they're right there and we can't go. And they get really mad at you and then they don't use your service again. And so from a very practical perspective, we're building a machine that can fly in those harsher conditions.
From a certification standpoint, does that make it easier or more difficult to get certified, do you think? As well as the conventional takeoff, I would think that'd be easier as well.
Yeah, so that's a great question. The answer is both. So it sets a very high bar. Flight into known icing is an additional hurdle that we have to overcome. But our configuration is very well known to the certification folks. When I talk, we have Dr. John Maris that's on our board. He founded a company called Certification Center Canada, essentially taking all the best certification folks from the private sector, sorry, from the public sector, bringing them into the private sector. They specialize in certifying new aircraft types and modifications to existing certified aircraft types. Um, we've put together a really strong program, and we feel that we will be successful as one of the first VTOL companies that will have an aircraft that is certified for flight into known icing, and definitely certified for flight into clouds under IFR conditions, which will be quite unique in the space.
So you're in Canada, obviously. Where else are you going to like to be certified? Like U.S. markets, Asia, Europe? Where else are you looking at?
Yeah, so the US definitely. So Transport Canada, in the Canadian regulatory body, has bilateral agreements with the United States FAA. So when we get certified in Canada, the bilateral agreements come into play, and certification under the FAA rules happens usually fairly quickly. So you don't have to go through a whole nother certification process. So that's North America locked up, TCCA, Transport Canada, Civil Aviation, and then the FAA certification follows shortly thereafter. We also have bilateral agreements with Europe, so EASA, the European regulatory body as well, in terms of being certified in Europe, and then we just keep rolling from there.
What about like UAE and Dubai, places like that? Like they're going gangbusters on these eVTOLs.
They really are. And Joby and Archer, they're doing great work over there. Yeah, in the UAE in Saudi, they have a different set of rules. They're a little more flexible, if that makes any sense. And so, if you have enough capital, and if you get on the radar at the right level, the certification process can be expedited. I know they're taking extreme measures to make sure that they're doing it in a safe manner, and that's good for the entire industry. And it's exciting because again, they get to start doing good work in the space a little bit earlier than they might have otherwise.
But what are some of the challenges and hurdles that you've been going through in development? And what do you see more as going forward? Is it's just a process?
Yeah, so we have an advantage that instead of doing what was popular, 3 or 4 years ago, and going towards an all-electric solution that would have driven us into a pretty tight corner from an engineering perspective. Uh, we said, listen, let's not do what's popular. Let's do what makes sense. Let's stay like classic product market fit. Let's build a machine that is laser focused on the end user and just build essentially a better mousetrap for operators. And that decision, although not popular 4 or 5 years ago, again, we had this jet fuel on board, which is very polluting to the environment, et cetera, et cetera. It turns out that that classic business model where you just try to build something that is going to make a safer, faster, cheaper product um, for the end user, that was a good business plan. And so we have stuck to that approach. And that's kind of what we're doing right now. Sorry if I missed that initial question.
So are you going to fly this yourself, do you think?
Oh man. So we just brought Mr. Jamil Janjua onto the board. Probably one of the most elite test pilots in the world. And so he might be the one that technically flies it the first. Um, Multiple degrees. He got, has been to space, so he flew Unity to space for Virgin Galactic. If I'm just being honest, he'll probably be the first one that actually flies it. I'm going to try to like suppress that info, and once he makes sure that it's safe, then I'll jump in and pretend that I was the first guy to fly it.
Well, but you are planning to fly it ultimately.
Oh yeah, absolutely. It's going to be hard to keep me out of that cockpit.
So where do you see this market going for you in terms of like next year, the year after, the year after? Is it gradual growth? Is it explosive growth?
Oh, it's pretty explosive. I mean, like you said, if you have a helicopter capability that's faster, cheaper, and safer, like significantly so in all those dimensions, I mean, there's no limit what you could do with this machine. Imagine getting people to the hospital in half the time at 75% less cost per unit mile, getting, radioactive isotopes for cancer research, getting organs critically to hospitals in half the time. Blade out of New York, they divested their passenger carrying operation, I think, but they did keep their organ transport business. Again, helicopters flying organs around, as it has been proven out, is a very profitable thing. If you could fly them at twice the speed at 75% lower cost, I mean, yeah, I mean, the business case writes itself. And so we do see it as an explosive growth opportunity. We just got to get this machine certified and into the market, which we have a solid plan for.
Do you think that's next year ultimately?
No, we will have a certified aircraft. we plan to have certified aircraft being delivered in low rate initial production to customers prior to 2030. So we're a ways off right now, but it's looking really good.
So it seems like the market for this is going to be like serious money market as opposed to like flying things could be a lot more lucrative than flying people.
That's right. And we're looking into cargo delivery, anything where you need to get stuff from point A to point B quickly and efficiently without the requisite runway infrastructure. I mean, our airplane will do that and do that in spades. So that's why the militaries are looking at it from a logistic perspective. The Marines want to use it to move stuff around and go and get people out of hotspots with the Army Special Forces. Like I said, anything where you need to go from point A to point B quickly and efficiently. Um, these new type of architectures are now possible from an aerospace perspective. It's really cool.
Can the military use these things before they're certified by the FAAs of the world?
Yeah, that's a great point. The answer is yes. So the military just wants things that work well. A great example is it should be unsurprising that, of course, um, the Department of Defense, major defense prime contractors are talking to us about the technology. One of them actually said, "Listen, we designed like honestly the same architecture, but you just beat us to it." Um, and yeah, and so those will be some initial use cases where we may maybe partner with the defense primes or the DoD to test this type of equipment, this type of aircraft. And when it passes their own internal safety requirements, which are a little more flexible, then it can start to be used. It doesn't have to go through a formal FAA type certification to be used for commercial use. The military can just basically go, yep, it's safe enough and it performs awesome. I want it and I'm going to buy it.
Yeah, I would think there'd be a lot of sales there before anything.
Oh, yeah, absolutely. Like I said, I was a military pilot for the better part of 20 years. I would have loved to have had one of these things in the capability spectrum.
The last question, a year from now, we're sitting here having this conversation about flying vehicles. What will we be talking about in a year?
Well, I think it's an exciting space. I mean, a year from now, I think we'll see some of the initial type certifications roll in. Maybe Joby's S4 will be type certified. Archer's Midnight might be type certified. Beta has been doing some great work, same thing. And you'll see them doing niche missions around the world and really helping folks out. Uh, from a Horizon aircraft perspective, you'll see some of the core technologies being proven out, and we'll be steps away from having a full-scale aircraft at that point, rolling out of the hangar. So we're building a full-scale aircraft right now. That should resonate with some of your viewers. And when we do so, we'll join a pretty elite group of companies that is a full-scale aircraft in flight testing, which should be pretty exciting.
I look forward to that conversation in a year. Thank you
Yeah,
so
me too,
much.
Chuck.
And
Yep.
thank you all for listening to the Voices of the Internet of Things. I'm Chuck Martin.
Thanks, Chuck.